Okay. All right. So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. I bid to our speaker for today, Prof. Sharifuddin Mat Zain, the organizer, Dr. Masmira, and Mr. Koyum as the technical person for this session, and all the participants. Thank you for spending your afternoon again with us, the Department of Chemistry, for the upskilling course. Just a friendly reminder that all participants to switch off their microphone throughout the session. And it will be very much appreciated if you can use the chat feature or the Slido web app in case if you have any questions for our speaker for today. I would also like to remind all the participants to have your attendance registered. Link to the attendance registration is already posted in the chat room. And there are also two other links that are posted there. So the first one is the link for last Tuesday's session. Okay, if you would like to review the session again, please use the link. And Prof. Sharifuddin also have posted a link for a survey. Okay, so if I can have everyone to help Prof. Sharifuddin in filling up the form for his presentation today, it will be very much appreciated. Okay, so ladies and gentlemen and students, without further ado, I would like to invite Prof. Sharifuddin for his presentation. Please, Prof.
Okay, thank you very much. Hold on, let me put my camera on. Right. You can see me?
Boleh, Prof.
Boleh ya?
Boleh. Terima kasih, Prof.
Okay. All right. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon. So today we're going to continue what we did last Tuesday. But the only difference is that last Tuesday was quite easy going, good. Yeah? But for this one, it will be a bit more tough. Now it doesn't tough meaning it's not difficult, but you probably won't be familiar with what I'll be talking about because these are actually quite specialized applications of computers in solving chemistry problems. But I just want you to hear me out. I will try to make it as diluted as possible to give you the basic ideas, how to actually jump the learning curve. You know, when you want to learn something new, you have this learning curve. It can be very steep. I will provide you with a ladder so that you can go higher, you know, and start not from the very beginning, but at least you have some ideas, ideas that will be crystal clear as you go along with the tools that I'll be talking about. Yeah. This requires you to do a bit of work later on, not within the 2 hours. A little bit of work learning these new things with the ladder that I'm giving you so that it's easier for you to learn. Yeah. Okay, so this is what we'll be doing in this part. Yeah, we'll be discussing about, we'll have a peek into the idea of a smart lab. Of course, when you graduate, you'll be working, right? And working here means that you will be probably working in labs, in big labs, you know. And the idea of smart lab will be quite apparent when you start to work with these big labs, because you won't be, you know, working in a lab like in the first year or second year lab. You'll be actually working in a very organized lab, and I think it is very important that you know what to expect of these labs. Yeah? We'll be looking at the electronic lab notebook as an integral part of the smart lab. This is actually part 2 or 2B. The first part will be looking at the other aspects of solving chemistry problems using computers. And we'll be looking at smartphones to do chemistry, some insights into Internet of Chemistry things or chemical things. We'll be looking at the importance of computer programming, and I will be stressing this over and over again, that chemists do not need to be computer programmers, but knowledge of programming will definitely help you out in a lot of things, especially when you want to solve chemistry problems. Plus, there will be you'll be using a lot of software. In these lectures, I'm not going to talk about another aspect of using computers to solve problems, i.e. Molecular modeling. If I would talk about that, it would take longer time, and it just doesn't give justice to the subject. So I'm going to leave that. I'm going to only talk about it a bit as far as the tools are concerned, in which you can use some tools in your smartphones to do chemistry. That's again computer programming. It is important that you try to learn programming, because it will allow you to develop a computational thinking mentality, which is very important, especially when you want to learn, say for example, new software. You're given a software without this idea, this background framework thinking, of computational thinking or computational framework in your mind, you will find that it will be a bit more difficult for you to learn. But once you have that computational mindset, then it's quite easy. Things become more logical and more commonsensical, easier compared to if you do not have that kind of thinking. So computer programming, I will stress a bit about that. The use of some tools, I mentioned it here, the use of Jupyter and Google Colab. And how do you make your smartphones chemically smarter? Well, not really your smartphones, using some things in the smartphone, allowing you to do serious computational, serious problem solving, serious chemical problem or chemistry problem solving using your phone. And you might want to get into machine learning and chemistry if you're interested. I will show you some examples about that as well. So these are the two things that we're going to do. But before that, let me get back to some of the questions that you asked yesterday. Okay, so we are going to look at these things: IO, Chem, P, smartphone chemistry, computer programming, But there was one question on Excel. There's a student who asked about, Prof, can you show us how to use VLOOKUP, HLOOKUP? And when I looked at the results of your survey on Excel, hold on, the computer is a bit slow. Let me show you the results. Wait a minute. Oops. Right. So there was this question, from the list below, which of the Excel functionalities you have never used, you never use it? And a lot of the functionalities, a lot of students have not used a lot of the functionalities, which is quite surprising to me, because I thought you use a lot of Excel, isn't it, in your undergraduate years? So things like advanced formulas such as lookup and reference, 59.8%. Get transform data, get data from text file, 68.5%. Forms of active controls, 75.6%. Macros, 84.3%. Now things like this are actually the core functionalities of Excel that makes it a very powerful software. So I'm going to show you a bit about how to just sort of a short demonstration of Excel. Showing you the how these functionalities are actually used, how they work, so that you can have more or less some experience and actually solve it or solve chemical problems using this knowledge. Okay, let me share you another screen. Okay. Right. Okay, what you see here is basically a table, right? I'm going to show you how to actually use the lookup and reference formulas. In Excel, many times, most of the things that you want to do is to actually do some calculations, but you want to extract certain data from a mess of data that you have. Now, this is not really a mess of data, it's just a small data. What I have here, this is actually a sheet that we wrote to convert different pressure units, pressure units. So you have all the units here, and the units there. Okay, so if I want to convert, say for example, from atmosphere to bar, I will multiply with 1.013254. Okay, so that's how we do it. And in order to do that, okay, so you have to put something in the value, okay, of the unit that you want, and convert it to the unit that you wish the pressure to be quoted in. So convert from, I see this atmosphere there, but I can have a drop down menu, so I can have bar or atmosphere, whatever I want, to another unit. Okay, right? So and I put the value, say 10 for example, and once I get that, this is the value that I'm going to get. So the value in millimeter mercury for 10 atmospheres is 7600 millimeter mercury. Okay, so this calculation is actually done using VLOOKUP. So if I look at a formula here, I'll click the cell there. If you look up there, so it uses the VLOOKUP formula and the lookup formula. So the lookup formula is applied to this table, okay, where it gives you, like for example, atmospheres, atmosphere 11. 11 here means the 11th row. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So atmosphere is at the 11th row. So what the formula does is that it looks for atmospheres. What is the number of row? Okay, it's 11. Then use the VLOOKUP in order to calculate the, or rather in order to get the number which is to be used in the conversion, and then multiply with the value that you want. Okay, so this is actually a sheet where you use these two formulas. Okay, how do we actually use that? Right, VLOOKUP is a formula that does searches in a vertical way, and HLOOKUP is a formula that does search in a horizontal way. They are actually the same, but if you were to change column to row and row to column, then you'll be doing the same search or the same lookup. But depending on what you're searching, either it is vertical or horizontal, then you will use the appropriate formula. Either it is VLOOKUP or HLOOKUP. Yeah. So okay, how does it work? So that's number 760 here. If I click there, that's my formula there. Yeah. So VLOOKUP consists of 3 parameters: C21, PRESSCON table, 8, and files. No, 4 parameters actually. Yeah. C21 is the value that we are we want to search. Okay, C21 in this case is actually atmosphere. Yeah. So the word atmosphere here goes into C21. PRESSCON table is the whole table, okay, that we are searching. And then 8, okay, 8 is the because we are looking for millimeter Hg. Millimeter Hg is the 8th column, right? So column 1, 2, 3, 4, 5, 6, 7, 8. Millimeter Hg is the 8th column. So what we're trying to do is, I want to search a cross between atmosphere, which is here, okay, and 8 with it, which is millimeter Hg. So the 8 here represents the 8th column, which is for millimeter Hg. So a cross between the atmosphere and millimeter Hg within the PRESSCON table. So I've given a name to the whole range of the data. I named it PRESSCON table. So C21 is atmosphere, something that crosses atmosphere with number 8, which is at millimeter Hg. Yeah. So atmosphere, where does it cross? It crosses at 760. Yeah. So what the formula will give me is 760. So the false here is telling me that you have to have the match has to be perfect. It has to be exact. Yeah. If it is not exact, then it won't. So there's another choice where you use true. Is the match is not exactly the same. So Excel gives you the flexibility of doing such search. Yeah? So that's VLOOKUP. Okay. HLOOKUP is the other way around. So what do I want to search? I want to search for C23, which is millimeter Hg. And this number here, what used to be column is now rows. So row number 2 is atmosphere in the table. Okay. So row number 2 atmosphere, which crosses with millimeter Hg, which is 760. There. So row number 2 and millimeter Hg, 760. Okay. Right. So that is it's basically the same search. You're just changing the column and the row. Okay. So VLOOKUP and HLOOKUP is in Excel. It is like pertinent. It is something that needs to be known. You just have to be able to use these formulas in order to be able to use Excel effectively. Yeah. Now in Excel 365, the new Excel, there is another lookup formula called XLOOKUP. XLOOKUP is easier. Yeah. It sort of it dispenses away the need to define which row or which table, table you have to define which row and which column. Yeah, specifically, you don't have to do that with XLOOKUP. Yeah. So what XLOOKUP does is, you look at the formula here. You still need to define, you still need to give, you tell Excel what are you looking for. In this case, C23, which is millimeter Hg. Yeah. What about the range? Now, rather than giving Excel the whole table, the range of the A column, which is from A5 to A17. Okay. So you just give the range of the column, and then the range of the other column that you're looking for, yeah, which is in this case H, which is the millimeter Hg. So it's just H5 to H17 from here to here. Yeah. So anything that crosses C23, and C23 is millimeter Hg, okay, it will give the value. In this case, what I'm doing here is, hold on, can you switch off the what do you call it? The speaker, your microphone, please. Yeah, thank you. Hold on. C23 is millimeter Hg. A5 to A17 is from here to here, and H5, which is here, H5 to H17. Okay, so it looks at it looks at millimeter Hg, which is here, right? And anything that crosses millimeter Hg for column for this column, which is from H5 to H17, is basically the value 1. Yeah. So XLOOKUP basically is a new formula that eases the use of, or the searching of data from columns and rows. Yeah? So these are the three very important lookup and reference formula. Okay. Getting data, you can actually get data from the internet, right? So for example, I have this link there. Okay, I'll just copy the link. Now, if you go to data, data can get data from this data ribbon, with this ribbon in this get and transform data part of the ribbon, there are a lot of different choices. So for example, you can get data from text, from web, from table range, or whatever. Yeah, database. Yeah, you can get data from well, many different things. Yeah, you can file. You can even read XML data, JSON data from PDF. You can also extract data from PDF as long as it's a good. Say for example, you have a PDF file and you have a table in the PDF file. You can use this functionality to get the data from the PDF file. So we want to get the data from the web, which is there. Okay. So just paste the URL there. Now, what Excel will do is that it will go to the URL, and for those who actually knows HTML, we know that the text in HTML has table tags and everything. So Excel has this functionality which is known in the programming world as we call it web. What's it called? But what it does is that it extracts data from a web page. Yeah? So that web page has a table. Yeah? Or web scraping. It's called web scraping. So it scrapes data based on what you define, what kind of data you want. So in this case, get data from web has the ability to look at tables. So if I click the table there, this is the table that I got. So I can actually have the web view, right? So there's a table where you have this world population and its yearly change and everything. Yeah. So you can actually get this data. Go back to the table. The table that you get, this is the table, and you can actually extract the table straight into Excel. So you go to transform data, and yeah, there you go. And you can actually manipulate the table even here. You can have keep rows, remove rows, you can split column. Yeah, you just have to play around to learn about this. And once you've got it, you just click what is it? Close and load. And what you get is that table in Excel form. Yeah? Now, the good thing is this. The good thing is this link will be live. So tomorrow, if the data changes, yeah, and you open up this page again, it will go back to the Excel will automatically go back to the table in the website and synchronizes the data. Yeah. So this is good because you can actually have if you have an Excel sheet where you want data which is live, then you can actually use this methodology. Okay. All right, that's your get data. Let's delete this table. And this is ActiveX. Okay, ActiveX. ActiveX is actually to make Excel more interactive. Yeah? So you can, if you have this, you can actually set up the developer ribbon. Yeah, to set up the developer ribbon, you have to go to File, and then you have to go to Options, I think. Yeah, right. And customize ribbon, so you can add, you can click to the developer tick here and click OK, and the developer window will appear. The developer ribbon will appear. So you can actually put in or insert form controls or ActiveX controls. You can add a button, for example, this kind of button. So you can associate the button with a code. So in this case, I have associated this button with a short code. So in order to look at the code, I right click the mouse and I view code. Okay. Right. So Excel will automatically set up this private window, okay, where I can actually put my code in a subroutine. Yeah. So if I just say message box, welcome. V3. V3. There you are. This is Visual Basic. If you know how to do it, then it will be valuable for you. Yeah, really, really valuable. Okay. Work. So go back. V3. V3, not V3. V3. Okay. Right. So now, if I were to, I put my name there, right, at cell B3. So I'll just exit the design mode. And when I click this button, hopefully, you will say welcome Sharifuddin. Yeah. So it's just a message box saying so this is Visual Basic basically, and you can actually associate any of the controls like the one I showed you, so a table or spin button, a drop down menu, whatever. You can associate it with either code or anything, almost anything. Yeah. So this one also requires you to learn a bit about it. It's not very difficult. It's very, very easy. You've seen how students learn this very quickly, and they used it in, if you remember, on Saturday, I showed you how Excel can be used to visualize molecules and rotate in 3-dimension, right? So these students actually use the form controls. Yeah? They use, say, for example, the radio button, yeah, in order to rotate the molecule, right? So these are the 3 things that I suppose will be useful. I'm just giving you some idea of what it can be done. Again, the learning Excel is not about going to process or anything like that. You just have to play around with it and try to solve your own problems. Yeah? Think of a problem. One way to think of a problem, this is what I did when I was learning Excel. I open up my physical chemistry book. Whenever there is a formula, okay, that allows me to say, for example, use the developer controls, X controls like spin button or radio buttons, which allows me to change values and stuff like that. I will use it. Yeah, so I can do things like change values and actually have Excel display to me real-time changes. So if it is associated with the graph, you can see the graph changes. Yeah, the molecule that you see rotates in 3-dimension. That is exactly the idea. What it changes is just the angle. Yeah, and the angle is associated with multiplication with rotational matrices, which changes the coordinates of the points, which represents the atoms in the molecule, and you see the molecule rotating. Okay, so that's Excel, very, very powerful tool indeed, and yeah, it's very, very useful. Okay, all right, let's go back to okay. Okay, so that is the answer to the question. There was another question. A student asked about JMP license. Yeah, JMP license. So JMP is actually a software, a statistical software used by at least one of the course. We have the chemometrics course. The license for this software has just been renewed. So if you want the new license, you can go to PTM's portal and download the license. Yeah, so it's already available there. So you can go and download your license file. All right. Okay, so let's have a look at what you know about stuff that we'll be talking about today. How many are you actually today? 169. Only 71 responses. Tak ramai yang respond. 71 responses. Let me share the response. How much do you use your handphone to do chemistry? Yeah. So many of you average lah. Yeah. Tengah-tengah. Have you thought of your handphone as a very powerful machine that allows you to solve chemical problems? Well, many of you actually know. That's very good. Do you have experience in programming? 28.2% says yes. So you do have some knowledge, which is excellent. Again, I would like to repeat: you do not have to be an excellent programmer unless you want to be, and it is even not something which is impossible. Yeah. You just need enough programming knowledge to be able to think computationally and solve chemical problems with, Excel or with VBA or other programming languages. Do you have experience in physical computing? No. Okay, so I'll be talking a bit about physical computing. The words like big data, data mining, machine learning, and deep learning sound familiar to you. Maybe not familiar quite a lot. Yes, 11.1%. So only 11.1% have actually have some confidence in, yeah, I've heard about this word. Yeah. I would like to repeat why I said on Tuesday that chemistry is a field. Chemistry is a field that actually produces a lot of data. Yeah, in the lab, for example, most of our labs are actually automated labs. I'm talking about university labs, but real labs when you go out to work, most labs are automated. So data just goes. The data is just generated, continuously. A lot of data, huge amounts of data. Molecules themselves, there are millions of molecules, at least 60 to 100 million known molecules. That's just the molecule. You're not even talking about the characteristics of the molecules, or when you do modeling or calculations or do something about the molecule, it generates more and more data. So these words, big data, data mining, machine learning, deep learning, for chemistry is like, something which is very close. Chemistry, when you talk about data mining, one of the fields that comes into your mind will be chemistry. Yeah? So if you're interested in data mining, it's excellent. You don't have to be an expert in it, but at least you know that it can be used to do a lot of problem solving and decision making. Yeah. Okay. So get back to the slides. Right, using your smartphone. Now, your smartphone is actually a very, very, very powerful device. It's really powerful device. When I came back from my studies in the first few years, because I was involved in using computers to do a lot of calculations, so the University of Malaya was quite in front in terms of thinking about this. So there were only two universities that has a supercomputer at that time. We call it supercomputer. We have in UTM there's a supercomputer, and then we also have in UM we have another one, which is the Cray J90. So Cray is actually a household name when you talk about very powerful computers. The brand is Cray. So Cray J90 is mini supercomputer, was bought by University of Malaya at that time in 1992 or 93. The cost is 1 million ringgit. 1 million ringgit is really huge at that time. Today, even of course today is still big money, but at that time in 90s, 1 million is really big money. Yeah? So we used to carry out a lot of calculations using this machine. One of the ways to actually determine the power of the computer is actually something called the floating point operation, or FLOPS. Okay? So there is a special program. You run the program, and then you push the program, you push the machine so that it goes as fast as possible, and then they calculate the number of floating point operations done by the computer when it is being pushed. So this Cray J90 was able to do 6.4 gigaflops. 6.4 gigaflops. That's huge amount of flops. My Samsung, I have a Samsung Galaxy Note Lite 10. I like the one with the pen, because with the pen you can do so many things nowadays, especially during PKP kan, you have to do signatures lah, you have to mark lah semua kan. So you have to have a pen. Pakai tangan ni tak, use the hands, not very nice. You either use a pen or you have a pad like this. This is a electronic pad, right? So either use the electronic pad or use a pen. So I decided to get my Galaxy Note. Yeah. So Note 10 Lite is a bit cheaper compared to the real Note. Now that smartphone has an Exynos 9810 processor. This is the normal processor, because in your handphone there are actually two processors. One microprocessor. One is the normal microprocessor, and the other one is for your graphics. It's called the graphical processor unit, GPUs. Yeah. So the Exynos has a clock speed of 2.7 megahertz, which is really fast compared to your J90. Yeah. Now for graphics processing, because when you do your graphics processing, you play games and stuff, you need a lot of processing, floating point processors. Just like in Excel, you're rotating the molecule, and each time you rotate, you have to multiply each point with the matrix, and then you get the different coordinate, and you have to plot the coordinate, right? So you need a lot of these floating point operations for graphical processors. So there is a processor called Mali G72 MP18 GPU. That is what is in my phone. Yeah? Now this Mali is capable of reaching 658 gigaflops. 658 gigaflops. Compare the 1 million ringgit Cray J90 with 6.4 gigaflops. It is able to reach 658 gigaflops, and it costs about 1,000 ringgit plus. Yeah? So what you have in your hand is really a very, very powerful machine. Very, very powerful machine, and you can actually use it. The only reason why a lot of people don't think about that, because handphones have become so ubiquitous, and it is so much associated with graphics. You play games, you watch movie, you do things with your handphone, that it would have been slow if you were to do scientific calculations, because other things in your phone needs to be processed as well. So people just forget about it. But the fact remains that your phone is a very powerful computer. It's a very powerful machine. I always look at my phone not as a phone. You call it smartphone, because you don't say smart computer. Where's your smart computer? You say it's a smartphone, right? So you use the word phone because it looks like a phone. You use it as a phone. Traditionally, when you hold it in your hand and talk to people, it's a phone. But in the real definition, your smartphone is actually a powerful machine with a phone. Yeah? So think of it as a powerful computer with a phone, rather than a phone which has a computer, which works on a computer. Yeah? So it is really something which is very, very powerful. Yeah? So of course, in your handphone, you have all these different software. I wanted to show you directly, but I can't seem to get my phone to work properly. Let me just try. Maybe I can. Hold on. Maybe I can. Maybe. Okay. All right. Mm-hmm. Something went wrong. No, I can't get it. Can't get it to work properly. Yeah, because nowadays on Windows 10 you can actually connect to your phone straight away, and you can actually see your phone screen on the computer, right? But I don't know why it's not working. Never mind. I've prepared for that because I have actually recorded some videos. Yeah, there you go. Okay, hold on. Before that, there are a few apps. There are many apps actually. Yeah, but I every year in the first year, I think you also saw my lectures. First year, I give sort of a 1 hour lecture to maths and chemistry students to tell them about the use of computers in chemistry. So there are a few apps like MoCube, ChemSpider, and a lot of other things available on your handphone where you can actually do real chemistry. Yeah. So have a look at them. Yeah. I particularly find a few very, very important ones like MoCube. ChemSpider to access databases, and iMolView to view structures including protein, 3-dimension. KingDraw, this is a very good software. I don't know, they give it for free, you know. It allows you to draw chemical structures, reactions and stuff like that, yeah, on your handphone. And of course, I also put Chrome and Termux here. I will explain later on. Yeah, but these are amongst the software. There are many other things, yeah, which you can play around with. So we're not talking about molecular modeling, because if we talk about molecular modeling, then as I mentioned earlier, it will be a long lecture. So you can watch this YouTube if you want to on molecular modeling. It's not a very good video. I find it quite boring and dry, but it gives you some idea of what molecular modeling is. Yeah. Right. These are the videos that I prepared for today. Right. So what I will do is I will share the screen, and I will just explain to you. Getting somewhere. Okay, right. So can you see the screen? Yeah.
Boleh, Prof.
Okay. Right. So this is my phone. Okay. This is the iMolView software. Yeah, you can look at 3-dimensional protein structures. Right. So I don't know what's wrong. I tried to get the spike protein for COVID-19 SARS-CoV-2. It sort of hangs and stops. Yeah? Anyhow, there's another software called OpenBabel, which allows you to transform from one coordinate form to another coordinate form. Yeah, you can do it on your phone. This is the KingDraw software. Yeah. I think this is a software from China. Of course, you can draw and draw reactions and stuff. Yeah. Full-fledged chemical drawing program. There is also a version in the web, sorry, on the PC, which you can use. You can get structure to IUPAC name, yeah, from this software. Very good, very nice. This is also good when you're using your OneNote as electronic lab notebook, because you can just get the structure and paste it. Yeah? This is MoCube. MoCube is actually a molecular modeling software where you can actually draw molecules, okay, and then submit the drawing, the molecule to a server, okay, and you can actually do some quantum mechanical calculations. Again, this is quite ubiquitous. A lot of chemists know about this already, just in case you don't know about this. So we have this phenol molecule, and you can submit. So I want the machine to predict the IR spectrum. Okay. No charge, electronic state is singlet, submit it. So it goes to the server does the calculation, and then posts back the results. So you can look at the results. This is the molecular orbitals. So I click the HOMO, or highest occupied molecular orbital, and this is how it looks like. Yeah, for phenol, sorry. Or the LUMO, lowest unoccupied molecular orbital. Okay, that's the LUMO, how it looks like. And you can also look at the spectrum, the IR spectrum. This is the IR spectrum predicted by the program. and you can look at the vibrations of the molecule. You just click on the peaks, okay, and look at the vibrations. Of course, the energy, if you look at this vibration, it is 858.92 wave number. Yeah, let's have a look at the OH stretch, 2800 wave number. OH stretch is about 3200, isn't it? 3600. So the calculations do not give the exact or the accurate frequency. It identifies the vibration, but the calculations are not very accurate. That's because of the theory level of theory used in the calculations. There is a protein VR. This is a very good program. You can download a protein structure and you can actually view it in virtual reality. Yeah, but you need a goggle, the Google VR cardboard to view it. You can also run. There is a site that gives you all the, what they do is they actually take in molecular modeling software, they ported it to Android, okay, and you can actually get the port and run molecular modeling software on your Android. Yeah, it's excellent. It's a very good software. Yeah. I will give you the link of the page later on. Okay. This is actually a statistical package. I actually used it a lot because it's very easy to use. So I can do principal component analysis, for example, on my phone. Yeah. What else is there? PDB mobile, RCSB structure, protein structures, protein data bank. There's also an app for that. I mean, there are a lot of these apps which you can just download and try them out. They are useful to solve chemistry problems. Okay. What's the next one? Okay, I'm going to show you this again. Yeah, but I'll just show you that it is possible for you to do programming, for example. There is an app called PyDroid where you can write a program. So I've downloaded, written a program on the, what do you call that? Brownian motion. You know, in school, you learn about Brownian motion. You put a flower, you know, this thing, and you watch it move around randomly, right? So we wrote a program on that. This is just a circle, and you can see the particle moving randomly within the circle. So if it goes out there, it comes back here. Okay, so you can actually do this as well on a laptop. I'll show you on a computer. I'll show you later on. But you can actually use your handphone to do programming. Okay. Right. What's next? This is the Mux. Okay. I think I'll show you this later on. This one. This is Colab Arbiter. Okay, this is also later. Right. So in other words, your phone is an excellent tool which allows you to do so many things. The sky is the limit. It just needs you to learn to try to understand what can be done with a handphone. It takes time, but it's worth it. Okay. Internet of Chemical Things. I just want to tell you that in UM we have in chemistry we have set up a space called the Chemistry Innovation Space. Yeah, where we can one of our intentions is to actually get students to get to know these things, you know, these microprocessors, and use these tools to build things. To help them in their experiments, for example. Yeah, so we have this space, of course, because of MCO. A lot of things are sort of can't do much. Can't go to the lab even. But this space is there. Yeah.
Sorry, bro.
Yeah.
Can you enlarge the slide again?
Sorry. Oh, this is sharing the screen. Okay, hold on.
Okay, thank you, Prof.
Kecil sangat Prof, tak clear.
Ya. Sekejap. Nampak clear tak?
Okay, Prof. Okay.
Alright. Okay. So a part of how computers can help us as chemists is actually through our use of modern microcontrollers. So the field is known as physical computing, where we actually do some computing. We do some programming, very simple programming, programming the microcontrollers to expect some input and to act in a certain way as the output. Yeah. So kita ada input coming in, and then our program that tells the microcontroller what to do with the input, and then the output is to do something. For example, the input will be a sensor from, I don't know, a thermometer. Okay. Now our program, the program that you write, is to tell the microcontroller if the temperature is higher than 40 degrees Celsius, then sound the alarm. So I will connect to the microcontroller. Okay, I will connect it. I will connect the thermometer to the microcontroller, and then I will connect a buzzer to the microcontroller as the output, and I will program the microcontroller saying that if the temperature is higher than 40 degrees Celsius, then sound the buzzer. Okay, that is the simplest thing that you can do. But this is the basic idea. Imagine the thing that you can do with only this basic idea. I have some input. I want some actions to be done. For example, and people have actually done this. He was my lecturer when I was studying, Professor Stephen Lay. He's an organic chemist. So this was early in 2010s, 2015, 2014. He has already published papers where he was trying, because organic chemistry has a lot of synthesis work, and so he was thinking of how can we automate synthetic work. Yeah. So because doing synthesis is quite dangerous, sometimes you have to leave the equipment for the whole night, and the whole day. So he puts a camera, okay, and then he connects to the microcontroller, maybe some temperature sensors or whatever, okay, and or look at the camera itself becomes a temperature sensor, okay, and then if the temperature increases or something is happening to the experiment, a warning is being sent. So maybe the microcontroller will send an SMS, or it's connected to an email, or do all sorts of things. Yeah, the idea is the same. I have an input. I want to tell my microcontroller what to do with the input, and the what to do is actually done by the output. Okay, so he actually did that, and he has actually published some papers. I have already left some papers. I have this paper here somewhere. Where is it? Yeah, the paper is entitled Camera-Enabled Techniques for Organic Synthesis. This was published in 2013, 7-8 years ago. And he has already thought about this 7-8 years ago. Okay, I'll just show you what I mean. I'll share it for you. So this was his paper. So he's now in Cambridge University. Camera-enabled techniques, you can see, for organic synthesis. There you go. So he uses a camera to tell him about something about what's happening in the synthesis process. Yeah? There you go. It's very interesting. Yeah? So he was the ones early on who thought about this term, Internet of Chemical Things. Yeah? So after him, there are a lot of other work concerning using microcontrollers like this to help you in designing your experiments. Yeah. So that is the physical computing field, which is now encroaching inside chemistry. I also leave you another paper in the folder, which I will give you the link later on. One of the papers that is written by some guy, there's a lecturer in Taiwan, who is really into this. Yeah. Okay, just go through quickly the kind of things that the kind of microcontrollers and computers that is available. You can buy on in Shopee and actually use it straight away. Yeah. We'll only look at 3 types. There are many different types today. One is Arduino, that's the most basic entry-level microcontroller. ESP32 is a microcontroller with extra features. Okay, and Raspberry Pi is actually a computer. It's a real computer, but it's very small. It's just the size of a card like that. Do I have it here? Yeah. Here it is. I'm not sure you can see it. Yeah, there you go. It's very small, but it is a real computer. Yeah. So this is the Raspberry Pi. This is ESP32, very small, and this is the Arduino board. So in our innovative space, we have a lot of Arduino boards. Students can come and try it out. You know, I've shown you the video of one student as her final year project. She designed an auto titrator, connected it to Excel, and you can see in real time the change in pH, for example. Yeah. Okay, I'm not going to go through this too much. I don't have much time, but I have a lot of links here. Okay, where you can go to for Raspberry Pi, for example. There are certain links, YouTube links, where Raspberry Pi is introduced, okay, to tell you what really is Raspberry Pi, and ESP32 as well. There are a few links there. This is the paper that I was talking about. Let me just get the paper and share it to you. Hold on. Screen 2. Right. Can you see? Elevating chemistry research, yeah? So I also left a copy of this paper in the folders. I will give a link later on. So this paper basically goes through the different let me make it bigger. Right. So he goes through the different types of microcontrollers, miniature computers, and some applications of it. So he a very good description about the different microcontrollers. There you go. Yeah, the different microcontrollers. The basic idea, the framework is still the same. You are trying to do something, so you have to program your card, the microcontroller, or the microcomputer. You have input coming in the form of signals, okay, that you get from sensors, for example, and an output. Okay, so the output can either be a digital signal that controls something, digital signals that allows you to send SMS, digital signals that connect to a web page, or whatever. Okay, so the microcontrollers and the computer is just a tool that inputs data, that obtains data from the sensor. You program it, and then the microcontroller or the microcomputer will do whatever you ask them to do, okay, based on the input that they get. Yeah. So this is a totally different field, which is, you know, a few years ago, people like us do not have that. We don't have access to do these things. But some clever people came along with a very good design of microcontrollers, which allows people like us who don't know much about electronics and computers to be able to do physical computing easily. Yeah. So I also have some examples, some videos of which you can watch later on. Where is it? Yeah, these videos, just there are many hundreds of them in the internet. This is just 2 videos which I think very interesting. There's one video. It's what this guy did was he actually connected a pump. Yeah, so you can actually automate pumping of solvent, for example. Yeah, you pump solvent from one container to another container. Yeah, so that can be done. Right. So I can't. I mean, it's not fair to talk about the subject within a few minutes. Just go to the YouTube channels related to Raspberry Pi or Arduino, and you get some idea of what's going on. Is it difficult? I've been giving my master students for the past, I think, 3 or 4 sessions, 3 sessions, yeah, assessments based on building projects using Arduino. So they are given the task to use Arduino to solve chemistry problems in the lab. Yeah, it's either automation, can automate some process, or maybe you have a tool that helps you in your endeavors as a chemist, things that you have in the lab. Can you automate them? So 3 sessions, and they find it something which is very challenging, not very difficult. The learning curve is quite steep, but once you watch these videos and know what it is all about, they get the hang of it. And at the same time, they learn how to program, they learn coding, and they do develop, or they did, or they do still develop computational thinking. And right after the assessments, they feel as if they can do anything. So that is the kind of feeling that you get when you get involved in physical computing. Yeah. Again, this is very cheap. Arduino costs about only 20 ringgit. Yeah, the actual microcontroller box. You can buy a kit containing everything that you need, all the components, and allow you to learn about a lot of things. That one will cost about 70 ringgit. Something that you can do actually during MCO and learn something new. Yeah. Okay. Right. Now, computer programming. This is to me as a chemist, it is essential to learn programming language. It is not wajib, but it's essential. The reason, develop computational thinking in solving chemical problems. And nowadays, computers just encroach upon us in every aspect of life. So, if chemistry, if you want to solve chemical problems, and because people have been using computers to solve chemical problems, you'll be difficult for you to catch up if you don't know computers and don't know programming in order to solve chemistry problems. Yeah? So, well, computer programming is quite essential for chemists. Huh? Okay, there are a few programming languages that I would suggest you to learn. Number one is Python. So next coming session, we are beginning the Python course. So chemists will be taught to program. Yeah, it becomes a wajib course now, Python language. Yeah? So it's extensively used. I will show you what I mean by extensively used in the field of chemistry for data analysis, visualization, and cheminformatics, bioinformatics work. In fact, for any chemistry work, when you solve problems with computers, Python language will come into play. The next language is actually VBA for Excel. I've shown you how important it is in last Tuesday's lecture, where you can actually use VBA to read data from various different sources, to do automation of your Excel sheets. Yeah? So my advice is to learn programming. And while this is MCO, of course you need to do chemistry work, but spend time. Spend about 6-7 hours. Some of the lectures on complete Python programming, for example, is about 4 to 10 hours. Yeah. If you don't learn, 4 to 10 hours will still pass. And after 4 to 10 hours, if you don't learn anything, then you are not you're no better than you were 4 to 10 hours before. So why don't you learn for the next 4 to 10 hours? Learn something new. Yeah? So after 4 to 10 hours, you're going to be somebody who actually have a good grasp of what computer programming is. Yeah. So don't waste that time, because if you waste it, it will still just time will just go ahead. It doesn't wait for you. Yeah. If you don't take advantage of it, too bad. There's another programming language called Julia. It's not really new. A few years, it's well, it's a new programming language in the sense that it's newer than Python or VBA. It's the community of Julia is still not very big, but Julia is very fast. Yeah, it's a fast language, easy to learn as well, just like Python. Okay, the syntax is like is human-like, yeah? So it's easier for you to learn Julia and Python because it is more appealing to human beings. Yeah? It's like talking to each other in human language. Yeah? So whatever language you choose to learn, learn programming because it helps you in your thinking, it helps you in your logical thinking, and of course develop this computational thinking, computational mentality. Yeah. Python is available for all platforms. I've shown you just now how Python can be used on your Android phone. Excellent, you know. Of course, in Windows there are many different platforms of Python. Yeah, I will show you one now. Hold on. There are many. The one that I'm going to show you is a platform called Spider. It's called the Integrated Development Environment, IDE. So you just type in Google, you know, Python IDEs. They will probably give you 5 to 10, maybe 15 different IDEs, yeah, for you to download, okay, and use. Okay. So this is Spider. Boleh nampak, eh? So I will open up and put the same program that we had just now. This is the Brownian program. So this is basically the program that to run the Brownian motion simulation. Okay, it's just a random movement. You have a particle, and the particle just moves in this direction and that direction and that direction, and all the motion is random. Yeah. So if you look at the code, even if you look at the code, is it possible to increase the code, the size? Never mind. So you will see things like this: random dot random. Yeah. So random dot random times 360 is basically randomizing the direction of motion. So you see the particle moves in all directions, right? Because it is randomized by 360 degrees. Yeah, that's the direction. And the distance is also random. Yeah, 20 at 10, 20. Okay. So the computer will find random integers from 10 to 20, any number from 10 to 20, and that is the distance of its motion. So there's a direction and a distance, and it is randomized. Okay. So if I were to run this, should be there. Can you see? So it's exactly the same as the one that I showed just now. So it randomly moves in all directions, okay, based on that random command just now. So this basically reminds you of the biology or chemistry class that you had when you were in school of Brownian motion. Okay, so if the particle goes out of the circle, it comes back here. Yeah, so it goes 360, so 180 degrees coming back into the circle. Right. So actually, this is one exercise that we gave in a computational chemistry class some years ago. Yeah. Okay, so you know, download any of the IDEs and give Python a go. Yeah. Now there are hundreds of chemistry-related Python modules. This is the key of learning Python. Right? One of the reasons why Python is so strong, because the chemistry community, a lot of people in chemistry who are also good in programming, you know, they write programs to help solve chemistry problems. Yeah? So a lot of the problems involving visualization, for example, yeah? These people, they are good enough to write and give the program for free to us. Okay, I'll just show you. Okay, so some of the awesome Python chemistry. So they divide it into different categories, like general chemistry, batch calculator, ChemLib, ChemPy, all sorts of things. Yeah, simulation, molecular visualization, database wrappers. Okay, so of course this is just a small amount. I know of hundreds of Python chemistry modules. So when you write a program in Python, or when you learn Python, what you know is just the basic framework of Python. It's just like learning a language. If you learn Bahasa Malaysia, for example, yeah, for one semester, you're not going to be able to speak Bahasa Malaysia fluently, isn't it? But at least you know the grammar, a bit of the grammar. You have a considerable amount of vocabulary as well, yeah? And you can make simple sentences. Yeah? So that is all you need in your programming knowledge. Because I will show you again what I mean by that is all we need. Because when you want to solve your chemistry problems, you can always use other people's codes. Yeah, you just search in the internet, there are codes. Okay, take the codes. You need to know about programming because you need to change the code. Yeah, so when there are important aspects in the code that you have to change that suits your problem, then you can change the code easily. That one I will show you later on. Yeah, so these are amongst the modules that can be that people have written for Python, using Python for chemistry. Yeah? And one of the strengths of Python is the fact that it is there are millions of contributors. People have contributed to Python by writing modules. Module is something that you will call. So when you write a Python program, you will call the module. You have to install the module. You have to know the module, of course, where to get it, download it from the internet, install it on your computer, and then you can call those modules from your Python program, from the IDE. When you're writing your program, you call the module and use the module. Okay. Now, in using the module, you have to know a bit of Python. Okay? So there are hundreds of chemistry related Python modules. Yeah? All right. I've shown you the use of IDEs just now. Yeah. I use the Spider IDE. Okay. Muntaka, can you switch off your? Yeah. All right. Switch off your. Muntaka, who is switching off? Okay. Muntaka, yes, it is Muntaka again. Can you make sure that your microphone is switched off? Yeah. Right. So the use of Jupyter or Jupyter and Google Colab has been something that is a new development. Rather than writing programs and showing to students or showing to people about how programs work, and actually writing important programs. So rather than using the IDEs, unless you're writing long programs, you have to use the IDE. But if the programs are short, and these short programs does something, yeah, you just say, for example, I want to input some numbers and then display the number in a certain way. So the code will be very short. Yeah. So rather than writing a long code, I want an environment where I can write the codes, execute it, and people can actually see right in front of their eyes how the programs actually work. So this is where your Jupyter or your Google Colab comes in. Yeah. Jupyter or Jupyter is a web-based interactive development environment for notebooks, yeah, for writing notes, for writing codes, to run codes and actually give data to people. Jupyter is good, but Google pushed it a bit further. What Google did was they implemented Jupyter Lab, okay, in their server, so that people do not have to install Jupyter Lab in order to use Jupyter to do coding and do notes and everything. Yeah. So what Google did was they built Google Colab. Yeah. It is an implementation of Jupyter or Jupyter in the web by Google. So you don't have to install Jupyter. You just go to this site. If you have a Google account, go to this site and you can program a code straight away. Now, another good thing is that if you want to learn Python, and you don't know where to start, you can go to Jupyter Colab and they will have examples, a lot of examples. Say, for example, introduction to Python programming. What you do is just you click to the examples and you have in front of you the notebook, the Jupyter notebook, or Jupyter notebook. You can click execute and see what the code does, and then there will be some explanation of what has been done. And then there's another code. You just click there, and it will get executed again, and there is an explanation. So just use Google Colab because it's very easy. I will show you later. Okay. Now, one very important module for chemists is a module called RDKit. RDKit. Now, remember in the first lecture, I told you, or I mentioned to you about ChemExon. Some of you guys have actually asked me, about ChemExon. They have downloaded and everything, and they like it. That's very good. Now, RDKit is actually something like ChemExon, but rather than having an interface like ChemExon, ChemExon uses the Marvin sketch, right? And ChemExon also uses Excel as the framework, where you have to download JChem and then install JChem in Excel, and you can use JChem through Excel. So that's ChemExon's way of solving this problem. There is another module called RDKit, where RDKit is basically a program written in C++, where this program has been wrapped in Python, so you can use RDKit module within your Python program. So you have to know how to program a bit using RDKit. But the reason why people like programming rather than using ChemExon is that when you are solving certain problems with ChemExon, it can be a bit tight. Tight here means, if it is designed to only do certain thing in ChemExon, you can only do that. But in RDKit, because you are using RDKit within the Python environment, you can actually do a lot of things that ChemExon cannot do, because ChemExon has been designed to do only that. For example, you have your formulas, right, in ChemExon, your JChem formula, JC, when we were looking at reaction, for example. But there are things that ChemExon cannot do because the formula is programmed only that way. What if I want to do it in some other way? You can't do it in ChemExon. That is why people would prefer to use RDKit. And RDKit is actually made easy, as I will show later on. Okay, so these are the things that you can start off with RDKit. How do we actually get RDKit to work? Now, RDKit is in Google Colab. It can be used in Google Colab because Google Colab works. It's a web application. So you can also use it on your phone. So as I've mentioned earlier, I can show it on my phone. This is the Colab. Let me show you Colab on the phone. Can you see the video?
No video yet, bro.
No video yet. Am I sharing the wrong screen? Hold on.
We can see your folder.
Folder.
Yeah, containing the 3 files.
No. Okay, this is the one. This is the one that you should be. Right, there's a video, right?
Okay, yep.
Okay, right. So this is all done on my phone. I go to the Colab. Okay, Google Colab. I click because I already have a Google account, so it's not really a problem. Okay. So I created a new notebook. Okay. So this is where I put my quotes. I will put my quotes inside here. So I install the RDKit module using this something called pip. Yeah, these things you just follow lah. When they say, okay, this is how you install this, just follow it, because that is how it is done. Eh? So I will install the RDKit package. Well, okay, done. Right. So what I do is I just copy and paste some of the things on the RDKit page. Yeah, I will explain later on when I show you on the PC what I mean. So I'll just copy and paste it into the Colab. Paste it and then execute it. Right, execute that, and I keep pasting. Execute and paste another part. Right. So I can do a lot of manipulation using RDKit on compounds like this. For example, if I want to put numbers, I want to put numbers in the for each of the atom. So I will run this statement. Okay. When I copy and paste this statement, I will get numbered atoms. Yeah. Right. So all this can be done on your phone. So if you know how to use RDKit, it will be excellent. There are a lot of things that can be done. Okay. Right. Let's have a look at RDKit actually as Colab function, how Colab functions, how Google Colab functions.
Daka, please mute.
Muntaka, your ni. Yes, thank you. Okay, so let me share different screen now. Right, so this is the Colab introductory page. Yeah, again, it's something that you have to learn now, but I will just make it easier for you. What Colab has is it has this code part, this text part, and then a code part there. Yeah. So imagine this: if you want to learn programming, I do some explanation here. I write something, and I run the code which is down there, and you actually see in real time the way the code runs, and with the explanation, it gives you some idea of why or how the code actually works. Yeah. So this is one notebook which explains the basic things about Colab. Yeah, but we don't want that, so we just create a new notebook. Right. So when the new notebook is created, what you see is just a code there, a code space. I can just write the code straight away. Print hello world. Okay. So that's my code. So if I execute the code, it will execute the print statement. Okay. And what I'll see is hello world. So it takes time, because this is all server based. It's not done, the calculations are not, or the code is not run or executed in your web page. It's actually done in the server. There you go, hello world. Yeah, so I can write any code I want. Yeah, in this case it's Python language, and wait for the execution result. Yeah. If I can also add text. This is the beginning of programming. Okay. Right. I add another code. There you go. So this is the beginning of programming. Yeah. I can write another code. For I in range 10. Yeah. And again. Same thing. Execute. And it prints hello world 10 times. 10 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 times. Yeah. So for I in range 10 means repeat printing it 10 times. Okay. So this is how it's actually done in Colab. So you print, so you write the code and just execute the code. Okay. And you will see what's done, what is the results of the executing the code. And if you want to explain how the code works, you just go to add text and add some more. Okay. Printing printing hello world. There you go. So it's very nice, isn't it? So learning Python is very easy using this. Okay. Now, what I'm going to do now is I'm going to install RDKit. When you learn Python, you have this basic framework of Python. Okay, it contains no modules, just things that are allowed within the Python basic framework. If you want to use other modules, you have to actually call those modules in. Yeah, how do you do that? You do that using the import statement. So if I say import, yeah. Oh, what about this one? Yeah, print. Random dot rand int I can't remember the keywords, but I want to show you that say for example, print cost 10. Yeah. So it says there's an error because Python does not recognize the word cost here. So I have to actually import cost, but I don't import that cost. I will import a module called maths. Yeah? Math. Math. Import math. So it is in the math module that you get the word cost there. Yeah. So I will have to do this. Print math dot cost. Invalid syntax. In cost. Never mind. I've not been programming for a while. You import the math, okay, and then you do something. In this case, getting the cost. I can't remember what maths. Python or maths module. So maths module. Done math.cost return the cosine of the number. So you have to do this. Once you have imported the math, then it's print math.cost. Okay, I'm not sure why it's not doing this correctly. Okay, so the point is you have to actually import the modules, then you can use the module. Okay, So I have imported, I have installed RDKit. Now I'm going to use RDKit to do certain things. The one that I showed in the phone, exactly the same. Yeah. So I have to actually import RDKit. Yeah. Okay, it's done. But of course, it's not just RDKit. In the module itself, there are many different functions that I need to use. So what I will do is I will just copy this. Okay. This is a way to actually import the different modules. So from RDKit import cam, that means from the RDKit module, import a function called cam. Yeah. From rdkit.cam.draw, there's another function within RDKit, import IPython console. Yeah. So how do I know all these things? You have to actually read the manual of RDKit, of course, in order to do that. Yeah. So I've done that. Okay. It's executed. Next code. Define a function. Execute again. And get a molecule from this string. Execute. So mole equals to cam mole from smiles. So this is a smile string. Okay. So using this cam dot mole from smiles function, right? Or in this case, the class, this smile string is then changed to a molecule, and it is placed in the variable molecule or mole. And then if I just write mole there, this molecule will be displayed. If I write again mole, for example, it will be displayed again, because that is the molecule that has been instantiated. Yeah? Now, if I want to get the numbers into the molecule, each atom is numbered. I have to run mole with atom index mole. Okay. If you look at this, there you go. This definition of a function. It defines a function called mole with atom index, right? And it uses the mole.get atoms and atom.setup atom map number in order to get the ID of the atoms. Okay. So once I run this statement, it is actually running the function, and it goes through all the atoms and labels the atoms with its index, with the element and the index number of the atoms. Yep. So these are just some examples that you can use RDKit for. All this seems a bit too much for you. Don't worry, because it is expected to be too much. The reason why I'm showing you all this is that, to show you, for example, if you want to be a good footballer, right? I don't show you some football player somewhere in Kampung Baru. I will show you, look at Ronaldinho or look at Ronaldo. That is what you should be aiming for, right? So by showing all this, you know that there are a lot of things to learn. So as far as resources of learning is concerned, there's just so much resources. It's just up to you to actually want or not want to learn. Yeah? Now, of course, RDKit is difficult in programming. So people try to make it easy, because RDKit also tends to generate a lot of data, right? So it seems logical to integrate RDKit with another software called KNIME. Okay, so the KNIME software, which I'm going to show now, is an analytical software. Hold on. Can you see? What can you see?
Yes, bro.
Nampak
Nampak,
Okay.
nampak.
Right. So this is something called the NIME analytics platform. Yeah. Say if you want to do a statistical analysis, you will first of all need data. Yeah. So the data is usually in the form of, because we always think in terms of Excel, kan? So the data is in form of table, columns and rows, right? And then what do? We then, okay, say start, first of all, I want to see if there are any cells which are empty. Okay, so you will go to the windows, sorry, to the ribbon, and look for if there is a functionality, find, you know, empty cells, for example. There is no functionality like that. You have to actually think about it, how you're going to do it, but the platform of doing it is there. Yeah. So, and then you start to do, okay, I want to do the calculations now. Okay, and then I click data analysis, and I will select the columns or the range of data, and I start to do my analysis. Yeah, that is the way of thinking that we always have. Yeah? But it becomes very cumbersome when there are so many steps in order to do our analysis. Yeah, we have to make sure that the data is integer, for example, or it is real number. We have to check whether the numbers are real or not, and then after that, if these numbers are not integers, how are we going to convert it? Are not real, we convert it to real numbers. If it is text, we convert it to integers and then convert it to real number. There are a lot of processes that we have to actually carry out before we can actually analyze the data. So NIME has a different approach. Okay, rather than thinking in terms of drop-down menus and what to do, NIME works in the principle of workflow. So if you look at this one, this is actually a workflow. You start off from here. The first step is to read the file. Okay, so NIME provides a lot of nodes. These are called nodes with different functionalities. So in this case, what we have done is we've installed RDKit in NIME, because NIME has an integration with RDKit. So one of the nodes offered by RDKit is read file. Okay, so I can read a file which contains the SMILE strings of structure. So if I look at the file, how does it look like? It looks like this. Yeah. So you have many compounds for each row, and these are the SMILE strings. Yeah, the textual representation of the structures, right? And this is just a label for each and every compound. So this is the SMILE string, which is read by here. So I just need to execute, and it reads. Now it has been executed. Okay, so the NIME has already read the data. Next, process the SMILE string. Okay, so it tries to process the SMILE string. If it is not SMILE string, then you send an error. Okay, and it changes. Say, for example, you look at this one. If it is not SMILE, then there will be an error there. See, failed to process data due to SMILE's passing error. So the data, the ones that are erroneous, you look at here. This is the output data and the erroneous input data. So the data which is not working. This is where the node which is supposed to read the SMILE string cannot process. Yeah, these SMILE strings are probably wrong. They have error. Yeah, so only certain ones, the output data, okay, is read. So you have your label of the molecules, and they converted it to a structure rather than SMILE string. Okay. Once it's read that, the number of molecules are quite a lot. Yeah. So they divide into two: primary amines and carboxylic acids. Yeah. So these two nodes process only primary amines, and this one only carboxylic acid. So what comes out here are only amines. If you look at the sample table, only amines. And what comes out here, only carboxylic acids. So what comes into the input into the row sampling node, okay, from the hundreds of amines here, take only 100. From the hundreds here, take only 100. So there will be 100 amines and 100 carboxylic acid. So at this point, this is the table. So 100 carboxylic acids and 100 amines. Okay. Then what you do is there's another node offered by RDKit called the two-component reaction. So remember, we were talking about ChemExon, where you react two things in Excel, okay, and it's actually very slow. Yeah, with KNIME is very fast. Yeah? So you will react amines, the 100 amines, to the 100 carboxylic acids. Okay, so it's like 100 times 100, so there will be 10,000 structures. Yeah, this is known as the enumeration process, if you see the number. Yeah, but this one is enumeration by reaction. So if you look at the product, okay, so this is your amine, and this is your carboxylic acid. This is the product. Amine, acid, product. Amine, acid, product. Amine, acid, product. So there's 100. So now 100 times 100 is 10,000 molecules. 10,000 molecules here. Yeah. If you use Excel, it will bog you down. Excel will get very slow, very slow, very slow. That's one of the problems of using ChemExon. Yeah. A small number of molecules, no problem, but when it becomes this big, it's very difficult. And yeah, in the end, you get the molecules that you want. Yeah, but there is no, say for example, right now there is no smile string, right? I want smile strings. So what I do is I find from here RDKit Canon smile. So I just drag it and put it there. I connect the output to the input here, right? And I configure the column that I want the molecule to be named, the smile strings to be generated is column product. Yeah. So new column name is smiles canonical. Smiles canonical. So okay. And I execute. That's done. If I look at the data, now I have the smile strings here. Yeah. Before that, compared to this one, there is no smile string, right? No smile string. So this one has the smiles string right there. Okay. So you can actually add on the nodes, okay, into your workflow in order to do whatever you want. So the data from here can then be passed to other nodes, yeah, where you can do data analysis. Yeah, there are many different types of nodes. If you look at analytics, you have statistics, different types of nodes for each statistics. Yeah, macam-macam lah. Yeah, you can actually, it's just a wonder to just learn about this. Yeah. Okay, so that is your KNIME Analytics platform. I have all the links, if you are interested in it. Okay, now let's have a look at the last part. I'm just going to go through quickly because we don't have much time. Told you last time that it's quite we call that unfair to talk about use of computers and computer skills in solving chemical problems in 4 hours, because it requires like one whole program, I suppose, just to talk about how computers can be used to solve problems. Right, let's have a new share. Okay. Right, Smart Lab. Smart Lab is basically a lab that actively uses the latest technology to manage its activities. Yeah. There's actually, did I give you this? I didn't give you this. Huh? I just don't have enough time. Huh? Just give you this link. This is actually a paste. So this is a link for the survey. Can you kindly answer the survey? For get data question, can Excel extract mathematical formulas from particular PDF, for example, article PDF? No, just numbers and table. Yeah. Prof, the Brownian motion code is also obtained from internet. This is something that we wrote. I put it in the folder that I will give the link to you later on. Yeah. Okay. Right. So you will be involved. You are working outside. You will be involved in working with big companies where you have big labs. Yeah, and these labs are actually controlled by it's an automated lab. So you have LIMS, yeah, lab information management system, all integrated. Right, everything is computers. Yeah, and one of the things that is very important is this lab notebook. Yeah, when you write your experiment, when you do your experiments, you jot down everything in your lab notebook. Yeah? And the thing about working in these big labs, smart labs, this notebook is not yours. You just write down whatever you want because your job depends on it. Yeah. Your experiments, your results, and everything should be placed inside the notebook, and this notebook is accessible by your supervisor. Your supervisor will be able to look at the notebook, anytime they want to. Yeah. And if they want to, they can also share your data with your colleagues, for example. Yeah. So that is your lab notebook. Yeah. Let's see. 70 people responded for your lab notebook. Do you have an organized lab notebook? No. Wow. It's 48.7%. How can you become a chemist without having a lab notebook? Lab notebook is the most important thing. Every single thing about your work should be in the lab notebook. Yeah? Let me share. Sorry. Let me share. It's very important. Nampak? Nampak tak ada survey?
Nampak, Prof, nampak.
Okay. So, do you have an organized lab notebook? 48% says no. A chemist must have a lab notebook. Okay. For example, if when we're doing computing, for example, we for each and different situation, we're going to run a program, right? So we have to know the file names. What are the things that are associated with these file names? Thousands and thousands of data. Don't have a lab notebook, how can you become a chemist? So please, you must have an organized lab notebook. Is it a paper-based notebook or based on note-taking apps? 24.4% uses these apps. Very good. Yeah. But the problem with these apps is that it's just yours. It's just you. Your supervisor might want to see, your lecturer might want to see it. In fact, that will be part of your marking. I want to see your lab notebook rather than your report. To be frank with you, lab notebook is more important than reports. Yeah. So I want to see your lab notebook. I want to actually comment on your calculations, for example. Yeah. Is the idea of electronic lab notebook familiar to you? No. Okay. Have you heard of using Microsoft SELN? Maybe, yes, and no. So yes says 29.5%, which is good. If you have used it, that is excellent. I wish all lecturers who are running lab classes use OneNote, or not OneNote. OneNote is one of it's a free thing, so you can use it, but at least use the idea of ELN, because you can get access to your students' work anytime. So your students yang malas-malas tu kan, yang just buat last minute, no, they cannot do last minute. After 2 days of doing the lab, I will go to them again and say, okay, where's your work? Why are you not doing anything yet? right? So it's like there's a pseudo interaction. You don't interact face to face, but you know what they are doing because everything must be done in an ELN, and that ELN is accessible to you. Okay, right. Let's go back to. Okay. So one of the most important aspect is actually electronic lab notebook. Okay. Okay. So there are some articles there. You can some useful links on ELN, and many people have actually used OneNote as an ELN, which is excellent. Some of them even say that it is better using ELN, OneNote as ELN is better than buying the expensive ELNs. Yeah. You can read some of the papers that I've given to you in this slide. Yeah, later on. Now the thing is, Microsoft OneNote is actually a note-taking software. It's not designed as an ELN. Now, why is it important? So ELN is like, you can imagine a paper lab notebook. You have dates, you have your data, your tables, your experiments. So by using OneNote, you can organize your experiments and everything. Yeah, and because it is shareable, it's very easy for others, your supervisor or your lecturer, to look at your notes. And this is very important. Yeah, I mean, people keep saying as lecturers that I don't know what my student is doing. So you should have implemented ELN. Then you know that he or she is working or not working, because you insist. Everything that you have done, you put in your ELN. Yeah? So I will know what you're doing, because it's not fair. Just because the student doesn't come and see you, he or she is not necessarily not doing work. Yeah, probably they are doing good work, but you don't see it. So a lot of independent students, they do good work even without seeing the lecturers. So it's good to have ELN implemented in student lecturer settings. So OneNote is natural on ELN. Yeah. Of course, there are many ways of actually doing it. It's available online. You can go to the web and use it, or you can use your apps on your phone to actually input data and everything. The only problem is that OneNote lacks some of the chemistry specific features like structure drawing and everything. But you know what? Just within this year, while it is an MCO, some clever people have developed a way to convert structured drawings that you do in OneNote into real structures. And you can even get the coordinates, the SDF coordinates. I will show you a bit later. Yeah? And the most important aspect of ELN is that it is shareable. Yeah? It is shareable, and it is searchable. If you organize your lab notebook properly, you can make it easy in terms of sharing and in terms of searching. Yeah? Sometimes you don't know where do you put your data. You can actually search for it. So it's very, very good. All right. So there is already an add-in that allows OneNote to recognize hand-drawn chemical structures. Yeah? Okay, let's have a look at how OneNote works. I mean, the best way to actually see how it works is to see how people use it. Yeah. So this is how I use it in some of my settings. Okay. Right. So this is the notebook. Now, OneNote in your say Windows 10, for example, there are two versions. One version is the OneNote for Windows 10, and the other one is the OneNote for Windows. So I like to use the OneNote for Windows 10 because it's clearer and it's nicer. But OneNote for Windows is also good lah. I mean, it's the same thing. This is OneNote for Windows, right? There are a few notebooks that I already have. So this is for my lab, SIC 23003 for this semester. And then there's an notebook as well for my master's class, yeah, right? Plus other things like that, my private notebooks. Okay, so let's have a look at the lab group. So these are the students. I can show you the student. So these are the students involved in the lab. Okay, so I'll have a look at one example. Okay. So each student will have a tab of experiments. Okay, and each tab will have sub tabs or sub pages lah. For example, experiment 1. Okay, so this is what she wrote, big idea. Okay. Okay, and she has a few pages, sub pages for each aspect, each calculation. So yeah, data compilation, right? And then some calculations that she's done, and I can give comments straight away. Yeah, most of the comments I use my handphone lah, so I can give comments straight away. I should have added another tab, discussion, so that I don't have to mess what they have done. So right now I have to write on the page that they are actually doing the calculation. I can just add another tab, share it with the others, and all my comments and everything can be done using that particular tab. Yeah. So some calculations, these are my comments again, references. Yeah. So you can see for each my comments again. Yeah, so with this I'm able to comment on the students' notebook itself. And students who are lazy, they are forced. I have to do something. I have to update my lab notebook, you know. So this is actually very good, solving problems of students' laziness. We are all lazy actually, but we try to be, to get out of the trap of laziness. Okay. Yeah, so it's another good example in the masters. Yeah, so this student even have a project tracker where she embedded an Excel sheet into the OneNote, and she tracks her what do you call that? Her progress in her experiments. Yeah. So you can put in any form of data, text, picture, voice, movie, into your space, right? And of course, your supervisor or your lecturer can have access to it. Now imagine, because this one is kept in the cloud, for UM, we have this Microsoft 365 in UM. So in 10 years, if UM is still having this contract, I still have my 10 years data of all my students within the ELN. This is very, very useful. I mean, I was like menyesal, because if I were to know about this long before, I would have used it, and I would have all my data, my students' data with me, all these years. But unfortunately, sometimes we learn things the hard way. Okay. Right. I told you about okay. I told you about the new add-in, right? Okay. So I can actually do this. This is very useful, especially when you write your notebook with a pen. I don't like to type, so I would invest on buying a writing pad, and a pen, and I can write it straight away. Yeah. So I can go to draw, and I can draw a molecule. Okay. And what I can do is I can select the molecule, and I can go to draw and click ink to molecule. It didn't read it correctly. Yeah, it should be OH there, right? Gives him CH3. But yet, if you draw it carefully, do it again. molecule. No, it's not. It's not reading it correctly. No, it's not reading it correctly. Yeah, anyhow, just to show you that it is now possible. So you can get this add-in, ink to molecule. So it makes using OneNote as an electronic lab notebook more more plausible, because now you can actually draw structures and convert the structures to molecules. Of course, you have to draw it properly, or else it's going to draw. It's not going to convert properly. Yeah. So you can already do this. It is already possible to do this. Okay. Oh, where is it? Hold on. Okay. Right, I don't have time to show everything, but that should basically give you some idea of how OneNote can be used to as an electronic lab notebook. Yeah, I mean, I don't just urge students to use it, but also lecturers, because it's easier, especially when you especially in MCO times. You don't know what your students are doing, but having an ELN where you can actually keep an eye. And you can even give extra tasks for them to do and monitor them based on the ELN. When there is no MCO and there's face-to-face, you can still use it, and it is still an excellent tool. So the add-in that we were looking at, in recognizing hand-drawn chemical structures, you can actually go to this link. You have to register and you have to download. But the one that we have is still a beta version. I mean, they are still testing it. I'm not sure when they're going to get release the good one, the officially released version one. But right now it is still beta. Yeah, but you can actually try that. Okay, right. I suppose that's about it. I'm taking a bit more than 2 hours. Okay, let's look at the questions here. In your opinion, is it an advantage more to people that have pen rather than typing mode in ELN? Yes. Yes. So it's like having a pen is like writing the actual thing. I mean, if you don't have a pen on your handphone, you can buy those rubber tip, right? It's still not very comfortable, but at least you can write down. Yeah. But buying a pad like this, I would urge, if you have the ability to do so, I would urge you to get the writing pad and connect it to your laptop. Is the 365 OneNote can be accessed by anyone without our consent? No. Yeah. So you say, for example, you are my student. Okay, I create a a classroom based on OneNote. So the only person who can access your data is yourself and me. Yeah, the others cannot access unless I give permission. Okay. How do you include timestamp audit trail? Right, timestamp audit trail in OneNote is dependent on this. You see, there's always a timestamp, Monday, 14th June 2021. So for each of the notes that you take in, there's always this timestamp. And I'm not sure. I think the timestamp depends on when was the last time you actually edited the file. It's the same as any other files in your Microsoft Office. Every time you edit it, there will be a timestamp of editing. So,
Prof, if you are showing anything, we cannot see it.
I'm not showing anything. No.
Okay, right.
Okay, so what else? Perkin-Elmer ELN, it seems can open ChemDraw file. Does OneNet? No. OneNote is not an ELN. OneNote is actually a note-taking app, yeah. But OneNote has the because of its ability to organize things, just like a proper notebook, organization, sharing, and everything. These are the specifications which ELN has. But ELN, because it is designed to be an electronic lab notebook, especially those designed by chemical companies, you can open, of course, different types of drawing software and everything. If you want to, you actually can have ChemAxon to open on OneNote. So you can actually open up ChemAxon in OneNote to draw structures. You can do that. But ChemAxon has stopped the support. I'm not sure why. They stopped the support for OneNote. Yeah. So if you still want to use it, you have to download an older version of OneNote. An older version of ChemAxon that allows OneNote to be open, OneNote to open ChemAxon Marvin Sketch. But they are not doing it anymore. So at this point, there is no software that you can open from OneNote. Yeah? There is no object embedding. You cannot do it with even ChemAxon, unfortunately. Yeah. So the only way that you can do it is to actually copy and paste graphics files, or use the one that I showed you, where you can have handwriting recognized by OneNote. Yeah. How does OneNote? How does OneNote relate to LIMS? Now, OneNote is a Microsoft app. LIMS is actually a system, Lab Information Management System. Within LIMS, one of the most important component is an electronic lab notebook. And usually in big companies, for example, they will buy a LIMS, and every worker will use the electronic lab notebook given by the LIMS. So it is integrated with the LIMS. Yeah, integrated with the LIMS. To the point that the workers who use this LIMS, use this electronic lab notebook, don't even know that it is the thing that they're using is an ELN. Yeah, because all the data that they put in will be deposited in the LIMS, in the lab information management software. Yeah, so yeah, that is the connection between LIMS and the ELN. It's part of the LIMS. Okay. OneNote, this is just an alternative, because ELN software can be quite expensive. And the next question, is UM going to buy ELN software? I really don't think so, because the ELN is usually used in an environment where you have a lab, what do you call that? A big lab, a smart lab, an automated lab with a LIMS system, where your results will be shared with all the others. Your supervisor can look at your results. Everything is integrated together. But in UM, you don't have that. But we do have the alternative of using OneNote to as an ELN. Yeah. Yeah. If you have a supervisor who, well, if you are a postgraduate student and you think that this is a good idea, go and talk to your supervisor. Use ELN. Yeah. And ELN that you have now, at least for now, is OneNote. In some of the links that I gave you, some of the papers, some of the discussion that people actually carry out, they actually prefer OneNote compared to some of the ELN in the market. Yeah, I'm not sure why, but of course it's because of the specifications and the ease of OneNote, because OneNote is integrated with the Microsoft environment, and maybe they are already very comfortable with the Microsoft environment. And OneNote can input anything, any form of data. All the different types of media can be placed in these pages, and they are searchable, and it's free, it's available. So it is a good idea to use it first. Wait for you and to buy ELN, saya rasa susah lah, lambat lagi lah, because there is no need for it. There is no need for an ELN in the current setup of the university, unless the lab is a huge lab where you do a lot of good research, a lot of money, and you want to make sure that all the research is actually kept in one particular, storage, then probably buying an ELN will be justified. But if you want to just buy ELN for students use, susah sikit lah. But there is an alternative, OneNote. Okay, any more questions?
We do have a few more questions, Prof, dekat Slido.
Right? Tak nampak, tak nampak kat Slido.
At the very top.
Very top.
Tak ada, Prof.
Okay, this
Tak.
one. Is programming skill important for organic or inorganic chemists too? As I mentioned, programming skill is not something which is wajib for chemists. A chemist can be a chemist without even knowing how to program, but it is a skill that is desired for. I know for sure, I know a few organic chemists who are good in programming, yeah, and they use their programming skills, for example, to do many different things. I mean, who developed, for example, all these reaction templates? They are organic chemists, and only people with good programming skills can actually do that, with strong background in chemistry, of course. Yeah? So it is not an imperative skill, but if you learn it, you will not regret it. That far I can say. You learn it, you will not regret it. Yeah? But of course, you are by default a chemist. So a chemist means you have to have solid chemistry background. Yeah. So an auxiliary skill would be programming. Yeah. Right, itu saja kan? Ada ke tak? Tak ada yang tak jawab lagi kan?
Ada lagi, Prof. Slido tu, that's the first one. To get, for example, the second one, for get data question.
Oh, dah jawab tu. Tak boleh.
Dah jawab tadi.
Tak boleh.
Alright.
The data, the get data tu, it can only get the a table, for example. Now, this one is because Excel has been designed to be that way. Excel has been designed to be that way. But if you know how to program, let me show you something. Yeah, okay, let me share first. If you know how to program, okay, there is a module called Beautiful Soup. A module called Beautiful Soup. So what this module does, yeah, is that it parses HTML, which means it is actually a web scraping module. So you use Beautiful Soup to scrape data from a web page. Yeah, it parses. Parse here means to actually it takes the data, yeah, and makes sense of it. Yeah, so you have an HTML coming in as the input. So the Beautiful Soup can make sense of the HTML and XML documents. Yeah, and then it creates the parse tree. So the sense that it makes is represented in terms of a tree, okay, that then can be used to extract data from the HTML. Yeah, so if you have a data, say for example, chemical formulas or mathematical formulas, for example, yeah, which has certain specific specifications. Yeah, because when you are in HTML, okay, you want to display a mathematical formula, okay. So the mathematical formula is not in the form of the formula itself, but it's actually tagged by special tags. So you can actually identify the special tags, right? Special tags that forms mathematical formulas when you actually see it on the screen. So using Beautiful Soup, you can parse for these tags and extract whatever you want to extract from the screen. Now, the only catch is that you have to know how to program. Yeah. So Beautiful Soup is a Python library, means it's a Python module. So in order to use it, you have to know how to program. Yeah. In fact, you can do so many things. I can't again, it's unfair for me to say, you can do this, you can do that, if you were to actually go into it, look at the different modules that you can use in order to extract things from the internet, it's unbelievable. Yeah, people actually go to the extent of doing all these things. And the good thing is that once they've done it, they give it for free. Yeah. And you just need to know how to program in Python in order to use these modules. Yeah. Yeah, so it's you don't have to rely on what do you call it? You don't have to rely on Excel. You can actually just program it if you want to. Yeah. Okay. Right now, I'm going to give you the hold on, the link for the folder that contains all these things that I've been talking about. Hold on. Okay, can you try and click that in the chat? See if you can get access to it.
Boleh, Prof.
Boleh ya?
Boleh.
Alright. So dalam tu ada 4 folders. Each one, mana-mana yang ada some of the things that I need to give information or files or whatever is actually in the folders. All the links that you may need is actually in the slides, so you can look at those slides and yeah, you know. Yes, so if there's anything else that you want to know, you can always message me or email me. It is always a pleasure to teach people things like this. So yeah.
Okay. Thank you, Prof. Thank you everybody for being here. Before we leave, can I have everyone to just open your camera and we'll just take a screenshot of whoever wants to join in. Prof, if you can stop sharing, we can see everybody's face.
Yeah. Wait a minute. Okay.
Okay. If you can have everyone who are ready, of course, to just open your camera, just take a screenshot.
Buka kamera.
Okay. I guess smile. All right. Nice to have Vinesh. All right. 1, 2, 3. Okay. Keep on doing that. Okay. I guess there's only one page.
One page aja. Alamak.
One page here yang is actually turning on the camera. That's fine. Thank you everybody for being here. Thank you for joining the department's program. I hope that in the future, if we do have something like this, you will definitely join us and upskill yourself. Okay, not just you guys. I'm actually learning something too from Prof.
Lagi satu, apa nama ni? There will be a recorded version of this kan? Recorded version.
Yes, Prof.
I think is it Mas Mira? Are we going to put it in the department punya YouTube kan?
Prof, untuk YouTube tu nanti saya contact balik Encik Koyum ataupun Facebook lah, mungkin Facebook ataupun YouTube.
YouTube boleh juga. Visibility Chemistry ada YouTube channel, so tak ada issue lah. As long as we have the video, we can upload it.
Yes.
Right.
Okay, thank you everybody. Thank you, Prof.
Thank you very much. Thank you.
Thank you,
Pleasure.
Prof.
Take care.
Thank you,
everybody.
Dr. Hadi.